Hello guys, so first let's test the audio and stuff like that. So we're not starting yet, but I think it's a good idea to test the audio at least. So do you guys hear me good? Oh. So apparently I think it should be possible to type in the chat. Let's see if you guys can hear me. Okay, I can hear myself, so I think we'll be fine. Nice, thanks. Oh. Yeah, so wait 3 more minutes before we start. Hello. Also, good afternoon to you, Petro. And also hello to Ali. Hey, Ahmed. So, do you guys also have, what's your experience level with AI? Of you guys? Okay, 2 more minutes to go. Yeah, so today will be about, well, as you already can see in the description, of course, about language and AI. Which of you actually already has attempted one of our meetups before? Or maybe just in a physical location? And 1 more minute. Okay, 1 more minute to go. Yeah, so there's like a 10 seconds delay between the video and the stream apparently. So I also have like a lot of questions like during the stream, like I want to ask you guys like what do you think and stuff like that. So it will be pretty delayed I think, but we'll find out. Hello Martin. Okay, I think yeah, I think it's time. 7:30, so I think we should start then. So let's go to the other one, like that. Yeah, so hello. Yeah, let's start the meetup. So today we're going to talk about training in AI to understand language. Maybe also like talk a little bit about ourselves first. So who are we? So yeah, we gave a lot of meetups, but in physical spaces before the Corona times, let's say. And we actually thought like a month ago, like the Corona is kind of like going down again, finally. So let's plan some meetups. But 1 month later, yeah, apparently Corona came kind of already back already. A bit annoying. So yeah, that's why we thought like let's do it online, especially with the heat. So like the Corona rise and also the heat. That together also I think too much for us, and we thought like let's just go for online. So who are we? Yeah, so I'm part of School of Data Science, so we give courses in artificial intelligence and data science and programming in Python in general, and also about was it like Internet of Things? We also do some things with that sometimes. Yeah, so we give courses mostly in time we do that in Den Haag and Rotterdam, but also sometimes at companies' locations. What else? And yeah, we also do sometimes consulting and stuff like that. Yeah, so it's a little bit about us. Yeah, so the topic for today, of course, like how does AI analyze text and stuff like that. So we'll probably look like something like this. We have a text, so it can be, let's say, one of the typical use cases, things like a review on IMDb, but it could also be like a book text or like captions of a movie, and then articles or papers or stuff like that. Hello, Rick. Hi. Yes. Yeah, so it can be a lot of different texts, and we just insert it in some model or artificial intelligence, and we get an output out. That can be something like a label, so maybe you want to label text, or maybe you want to extract information, or maybe you want to generate text. So yeah, stuff like that. But I don't want to go too fast. Yeah, so of course the question is like, how does it work? How do all these steps work? Like, and also like which applications, stuff like that. So yeah, that will be the main topics of today. So first we're going to talk about applications. So why and when do you want to use it? Then how do we connect the written language with the language of the computer? And then of course we're going to talk about the models, which will be of course the harder part. Yes, so we also will probably have a small break, and we will do that between the human language to computer language and the models. So we have like a small break in between, like that you can go to the toilet and stuff. So yeah, the first part, applications. So yeah, normally I would always just give it in a physical space. So I would always like ask the group like, what can you think about? So, but there will be like 10 seconds delay, so I will wait for a while. So what kind of applications can you guys think of? Why do you want to use a AI to analyze text? So what kind of applications are there in the world? So you can also like think of like, what do you see on websites, or what do you see on your phone? Which kind of applications of AI with text are out there? Don't be shy. Let's see. Yes, Google Translate, of course. A very good one, yes. Photograph translation featuring common ones I use. Photograph translation. Yeah, do you mean also like captioning or stuff like that? Photo captioning? Text transcription, yes. Chatbot, of course. Summary, text generation, scanning documents, auto-completion. Yes, yeah, there are of course very, very good examples. Yeah, so I also had a few, a lot of them the same as you guys. Let's see. Yeah, Google Translate, very common one, of course. It's actually pretty decent now. It used to be pretty crappy before, but now it's pretty good. So you can just insert like a language like English and just translate it to Dutch. I actually think I use more translating from English to Dutch than Dutch to English nowadays, because I always write text in English and then I have to translate it back to Dutch if I have to use it in Dutch applications, stuff like that. Classify sentiment classifying. So let's say if a text you want to maybe add a topic, so you can also maybe like think about it's also more like maybe chatbot related, but like you have like a question and you want to redirect the question to the right person, so you can also like do that with classification and stuff like that. Yeah, indeed, like Google Translate is really bad. Like also you have to do those kind of like jokes or stuff like that, where you insert like one language and you do translate it to English and then back, and you will get like a totally unethical answer, let's say, and it was pretty funny in the beginning. Yeah, so but also like things like autocomplete, so you just have a sentence and it will predict the next word. Of course, your phone does that, but also like email's already pretty good at it. Like I use Gmail, and sometimes actually it all kind of like predicts a whole sentence, and sometimes of times it's actually pretty good. So it predicts a whole sentence which I kind of want to say. So yeah, that's pretty nice, or creepy, whatever you think. I think it's pretty cool. And yes, also like image captioning. So let's say if an image and you want to add a caption below, that can also be done with AI. Also like yeah, there's maybe something else, but I've also seen an AI. Nah, yeah, maybe you can also like do it from video, but nah, that's a little bit different. So yeah, I also made one application myself a few weeks ago, so I also want to show you guys this one. So it uses GPT-2, this one. So I made a fun application which makes fake recipes. So this was like a fun project for me. So I just had a recipe generator. Let's see, I think I got a better one. I don't know, like this one. That's better, more steps. So I just have this one, so it will predict the title of a recipe, then it will predict the categories based on the title, and it will predict ingredients based on what was before, and then it will predict the instructions, and it will predict the reviews. So this is all generated with an AI. It's pretty fun. So I also want to make a video about it on YouTube soon. This is pretty fun. I also actually made one of the recipes, and it was actually pretty good. I also, so I almost had a local startup space. I put the cookies over there, and people thought it was like pretty good. So it's nice. Yeah, it was like a fun project. Yeah, so you can do like a lot with text generation, and you don't even need a very huge computer for it. Like I used my home computer to train this one. Okay, I have a pretty good computer, but still, it took like 18 hours, I think, 18 hours before it was pretty good. So yeah, it's doable, like one day. What else? Yeah, so this is about applications. So I think most of you guys can think of something. Yeah, but now of course we have to think about like how can we make our human language understandable by computer. So we have written language, we have like words, but we want to put it inside a model, and that's not that straightforward actually, because yeah, like you maybe you're like thinking like, oh yeah, maybe you can make a picture of it and we'll try to read it, but it's like, yeah, maybe one day it can do something like that. I think you can already like add multiple models and you can achieve something like this. But yeah, so you want to insert text into a model. So what kind of things can you think of? How can you insert text inside a model? So be creative. Let's say you have some text and you want to make it computer understandable. I think probably some of you already know kind of some of the right answers. There's also like a 10 seconds delay, so that's why I have to wait. Tokenization, indeed. Yes. See if someone else also has some other things. So for tokenization, of course, we're going to talk about that because that's what you do almost always. Okay, I think that will be about it. Yes, so indeed I will also talk about tokenization. Text matrix, yes, indeed. That's also another operation which is kind of like same in some way. Yes. What else? Yeah, so first I'm going to talk about like a small thing you can do, which is called like bag of words. So what you'll do actually is just, let's say you have a sentence and you'll just count every word. So you will count the amount of times you see the word this or is or a or sentence. You will count every word, and you will just make one big list where you say like word one, maybe there was like 0 times the word one, and maybe like there was like 5 times the word the, or like 3 times the word a and stuff like that, and you will count them. You can also do the frequency, so you just have all the words and then divide it by the total number of words, which I did in this example. So here you can see, you can see my mouse, nice. So here you can see, let's say, the frequency of every word. So there's like the word the, let's say the first word in your way of thinking. Let's say there's no the in the sentence, so you put a 0 over there. There is one is over there, and which is like 25% of the whole sentence, so you put 0.25 there, and same for the other ones. And you can do that for many, many words, and that's like one way you can do it. Of course, I could say there's one big drawback. Yeah, so the drawback, of course, is that you lose like the whole concept of relations between words. But actually, this method works for some applications pretty well. So let's say for the for reviews on IMDb. So maybe you want to predict if a review is positive or negative. And this already works pretty good. So for example, if someone uses the word good or great or amazing, then you're pretty sure that the review will be positive. So by just counting those words is a really good indicator. And of course, if someone says bad or horrible or awful, then you know, of course, that the review is probably negative. So that already works pretty well. So if you do that, I think, yeah, you can already, let's say, get an 88% accuracy to predict if a sentence is negative. So you can do something like that, which is, of course, a little bit of a easy method, but it works. Yes, other methods, like mentioned in the chat as well, is tokenization. So that is saying that you just replace every word by a number. So for example, the word this you replace by number 1, the number is by 2, a by 3, sentence by 4. Because we just have 4 words, you can just put those 4 letters. Of course, most of the time you have way more words, so you just make a dictionary first, and you just replace them based on how based on the dictionary sentences. So most of the time, the dictionary is also ranked on the most common words till the least common words. So, for example, the word a is very common, so they will be having a very low number, whereas the number sentence, that word is very is not that common. So you put there a high number like 420. So that's like one method to tokenize a sentence. Yes, you can also like do some smarter things, and this helps in some cases. For example, stemming. So let's say you have the word swimming, swim, swam, swimming, and those are kind of similar. So in some cases you just want to replace them with a common word because the meaning is kind of the same, and that's what they do sometimes. Another thing is remove the bigger letters, like uncaptionated. That's also one thing you can do. Removing stop words like a, this. For example, for a lot of use cases, it's not very useful to know if there's an a or this, and you just remove them because less data is better for some cases. But if you, of course, you want to generate text, then you want to have the a, the this, the d. You want to have those in your sentence, of course. So it's not always useful. And removing characters, so the hash or the dollar sign, you just want to remove them if they have no additional meaning. So that's also done sometimes. Yes. So you also have, like, let's say, a bit more advanced tokenizers, and they just also split less common words in parts. So let's say you have the word this is a sentence. Then the word sentence is probably not a very common word, so that can be maybe split in sentence, and that's also like one thing you can do. So the good thing about this is that, well, you don't have to include the whole dictionary to include every word, because that would be horrible to have the whole dictionary as your input. And also, like, if someone makes a spelling mistake, then this will not, the correct word will not be included. But now, if there is a spelling mistake, then the word will still be there, but in a different form. But maybe the model can also learn that the spelling mistake means the other word, so that can also help. So the more advanced models use something like this. Yes, are there some downsides of using tokens? Like, of course, for sure we're going to tokenize, but there's still some things. If you just do this and you just stop there and insert in the model, there are some downsides. So I want to know if you guys can think of what can go wrong if you will just use the tokens face value without any other adjustments. So what can go wrong if you just use the token values without any other application processing? No thoughts yet? Yeah, so also like probably kind of similar as indeed one of the things I mean, that similar words have different tokens. So let's say words are quite the same meaning, then they have completely different tokens. So they also like so they have to be learned separately. So that's indeed one of the drawbacks. Yes. Yeah, so I will also like talk about a few examples. So for example, one thing is there can be a huge amount of tokens. So let's say you want to insert the whole dictionary, then you probably have millions of tokens, which is horrible. So there are easily, let's say, way too many tokens. Yeah, there will be a lot of tokens. So a lot of tokens means a huge data set, and it can be kind of annoying. So yeah, that can be a problem. Also, one thing is like words with different meaning are quite close. And if you are, let's say, very naive and you just use tokens as a value, then it can go wrong. So, for example, let's say you have a model, let's say you have a brain cell, and we'll just get some values like word 1 has the value 2, word 4 has token value 4, the word 3 has token value 3 and stuff like that. So then it will be, let's say, it has to specifically know that 10 means this, but let's say the word also like in this case, the word moon is surrounded by the word house and dropping, for example. And those are completely different meaning. So it will probably easily mistake different words because it has to specifically know this value, and that doesn't really work. So what you want to do is, let's say, make them separate. So you want to have that, let's say, it will have, let's say, an input like the word 1 is not this word. Word 2 and word 1 is also not this word. Word 1 is also not this word. Word 1 is this word. So you want to really separate it that will never confuse one word with another word. Like most of the people probably do this right, but it can be, so maybe if you just do it for the first time, you will just insert a token value as the input of your model and it will go wrong because it will easily mistake different values from for other words. So yeah, that's like one thing which can already be improved. But of course, like, so yeah, this is called categorization. So you just categorize them, or you also like dummifications, that's another word, or like one-hot encoding. There's another word for it. Yeah, so if you just do it like this, then of course you get a huge amount of inputs. Yeah, so let's say if you just do this, you get a huge amount of a huge input size, because now you have, let's say you have 9,000 different tokens, and let's say you have 400 different words, then you have 9,000 times 400 input values. That's like a very big number. So that can also be a problem. Yes. Also, words with similar meaning are can also be like totally different values. That's kind of like, or like words with similar meaning can have totally token values. That's kind of like the same as you said in chat. So yeah. So you also maybe want to have something that words with the same meaning have the same number. That's also like something which might be beneficial. Yeah, so we can solve this using something else, which is called embedding. So instead of just having a one-hot encoded vector for every word, so you will just have a vector with a way more dense packed vector. So it will be smaller. So not every word has its own dimension, or not every word has its. So it will not be just one with just zeros, but it will be that every dimension always has some value which indicates some aspect of the word. You can do it if you do it in a smart way, then words with similar meaning will be more closely together, and words with different meanings or totally different meanings will be further away. So that's what you can do, and this is actually a pretty good method. So you can make your input way smaller. So yeah, this is how I think about it. Yeah, also like another problem which is left, it's maybe a small one, because we also have the same thing still. Let's say you have a word with the same spelling but different meaning. For example, content, It can also have two different meanings. Capital can have two different meanings. The word lie can have two different meanings. And those things are still not solved, but like that's also like what we have as well, right? So if you see a word, then it just can have a different meaning. So the model has to handle that still, but I will. Yeah, so how do you get an embedding layer? So one thing you can do is just steal it from someone else. So like you have let's say an embedder, an embedding layer which is called a glove. You can also like use it from other models like Google has a model called BERT, and they also have their own tokenizers and their own embedding layers. So you can also use those, and or you can just make one yourself, which is actually pretty doable. Yeah. So to summarize, how to communicate between a computer and or between human language and a computer. So one of the methods is bag of words. So just count them and have one big list with all the counts for every word. What else you can do is tokenize them and make them a category. So let's say you're 100 encoding. So you have just like all zeros and just one at the token value of that specific word. And the best method, which most model use, is embedding. So you have just like one vector which represents some word. Yes. So I think this is maybe a good time for have a small break, maybe for like 8 minutes, so we can start at 8 o'clock. Yeah, so if you have some questions in the chat, you can leave them in the chat. So I think it will be good to just continue with the model parts after 8 minutes. See you in 8 minutes. Break. Okay, I think it's about time, like 8 o'clock, so nice. Yes, so let's continue. So now we go to the model. So we are all experienced, of course, with the problems and how you can connect language with a model. So now about the models themselves. Yeah, so most of the time I would just like ask ideas, but then I have to wait like 10 seconds again, so I'll just show them myself. So like one of the earlier ways to do this is like a method called naive Bayes, or yeah, something like that, where you just assign like every word with a value. So for example, the word I you assign with 0, hate maybe with a negative value, and love with a positive value. That's what they did to assign if a sentence is positive or negative. This is of course a pretty old method, but yeah, it's also nice to see that you can also do it with a pretty simple, understandable way, and still pretty good results. Yeah, but we of course going to use a bit more advanced models, and for that I need to explain a little bit about deep learning. So I will just give you a small introduction in deep learning. Probably a lot of you already know it, but just to make sure, I will just explain it. Yeah, deep learning, it's or artificial neural networks in general, is like based on yeah, it was like, or like the origins was a bit about a bit similar to the brain cells of humans and other animals. So let's say in this case we have 3 brain cells, and this one is this is the input over here, and this is the output over there, and the output is connected to this one. You also have like a neuron over there with input here and the output there, and it's connected also to this one. So this neuron is listening to these 2 other neurons. For example, in the human brain, I think you have like 100 billion neurons, so it's way more. And every neuron has about 7,000 connections. Yeah, so this was like, I think, one of the original, ideas, or the original inspiration to start artificial neural networks. Now, normally in your brain, or in any brain, neurons are just sitting still, they're doing nothing. But maybe they get triggered for some reason. Maybe you're thinking about cars, and this neuron is related with cars, or maybe one of a particle hits your eye, and maybe one of the neurons gets fired down the chain, and maybe the neuron which is listening is not really affected. But maybe if both neurons are triggered, so this one and this one also be triggered. It could also be like that these 2 neurons are weakly linked, and these 2 are strongly linked. So like every neuron has their favorites. So that could also be the reason. But yeah, this is kind of like the one-on-one on like brain cells. And yeah, they also have like activation. So or they fire or they don't. And there's, let's say, a probability, of course, like in the brain, nothing is really perfect. So like you have like a chance that it will fire. Although in the human brain, it's or one is on or one is off. You do not have values in between in the brain in itself. So of course we want to model this kind of concept in a computer. So I will show you a very simple example. So let's say you want to decide if you want to eat frozen pizza today or you want to cook. And you want to have a model which will predict what you will have to do today. So you can insert your laziness level, the number of days ago you have cooked, and if your parents are coming over. So this model is like similar to the brain, that it's like every node is like one neuron, where neurons are also like connected, like this layer is connected with this layer, and this layer is connected with this layer. And where the input is, let's say, let's say if they have this neuron, then the input will be represented by this arrow, and the output will be represented by one of these arrows. So let's say today you're pretty lazy. Let's say you give it a 1.8 value to be lazy today, and you have recently cooked, maybe like yesterday or something, and your parents are not coming over. Then what you can do with a neural network, you can calculate the next layer based on those inputs, and then you calculate the next layer. And then apparently the value for frozen pizza is higher than cooking, so you will eat frozen pizza. But maybe your parents are calling and they are coming over, so you flip that value and you have to calculate the 2 layers again, and now apparently you have to cook, probably because of your parents are coming over. So at this moment, you're maybe wondering like where do these values come from, like how are they calculated. So at this moment I would just call it magic, but of course it's all math. Yeah, so every neuron, I also said before, like have their favorites and stuff like that. So this neuron can maybe weekly listening to this one, like about okay listening to this one, and also weekly listening to this one. And what you will do, you multiply this value with this value, this value with this value, this value with this value, and you will add those three multiplications together. That's one of the first steps you do. And then you will also add a bias. This is a value which, let's say, gives an already initial value, kind of like it will already give an offset that will be easier triggered or weakly triggered. And then you will apply an activation function. So it can be something like this, and that will give the dynamics of the network. So activation function really, really important. Without activation functions, the model will not be very interesting because it will be just a linear function, and it will not be, it will not have very special, not very special abilities. So the activation function is very important. And then that's about it. That's like whole of artificial neural networks. It's just multiplications, additions, and stuff like that. Yeah. So of course, the most important values here are these values. These are the trainable parameters. So those are values you have to train to have a good network. So you have to obtain them some way. And that's what you do during training. This was like a whole topic on its own. So, but yeah, you can just think them as values which you need to get in order to have a functional network. So yeah, let's now incorporate this what we already know about the words. So let's say we have the words this is a, like here. And then we want to insert that in our network. So you have to, of course, first to tokenize them. And then if you would have one hot encoded them, it would be something like this. And then of course we do word embedding, and you will get something like this. So what you can do is just add all these factors together, and let's say you have one big list of all values. Whoa, sorry about that. One big list of values which represent the sentence, and that is something which you can insert in your neural network. So for example, you can insert the first embedding value in the first neuron, second embedding value in the second neuron, till the last one. Let's say you have 42 words, then you will insert the last embedding factor of the last words into the network here, and then you can do something magical. This can be, for example, classify if a sentence is negative or positive, but you can also do something else. It really depends on kind of like your use case. So this is, let's say, the most simple, the simplest model you can think of. It's called like a deep or feed-forward network or deep feed-forward network. It depends kind of like on how big your network is. So yeah, this is one simple model. I also like add in the top right corner like how difficult the model is. So I think maybe the first ones you can probably kind of understand, but if you go along, probably the more difficult ones, yeah, they're really difficult. So if you just kind of like squint your eyes and kind of understand them, that's already, I think, the goal with the harder ones. Yeah, so you can also like improve this model a little bit, and that's by adding convolutions. I'm not going to talk a lot about this one addition, but you can see it as, let's say, having additional local operations that results in that words which are, let's say, very close to each other, that you will give them an additional separate calculation. So let's say if you have three words next to each other, then you will just combine those three words in one concept. That's kind of what you do with convolutions. And so if you would complete this whole model, you'll get something like this. So we have this sentence, like this movie is very bad. You will tokenize it. Then you can also like do categorization, but most of the times you don't do it. Then you do embedding. Then you will apply the convolutions, meaning that you group words together. And then you will add all those three vectors together. And then you have your whole sentence, and then you can insert it in your neural network. If there are any questions, please let me know. I hope this is kind of clear, especially because this is one of the easier models. So yeah. A little bit harder model is a recurrent network. And this is a network where you insert a word one by one. So how does this work? Let's say you have a word, you insert it, you make one big circle, and you insert the output again in the network, and that's what you do multiple times. So to make it a bit more clear, first, let's say you have this word over here. In this case, it's pre. You will insert this in your network, in a small network. The output will go back in the model. And you can also, what you can also do is have the output as well go to 2 other layers and then put it right here. So what you can do is insert one vector in the model and the output will also go out. That's an option. What you can also just do is just only the last one. But oh well. So first, the first word, you make one circle, the output goes back in, you add the second word, you add the output once again back in, the third one, the fourth one, until you have inserted all the words. So you go, in this case, it's 16 words. So you'll make 16 circles where you insert one word, output back in, word, one word, output back in, and you do it 16 times, and then you will have the final output. This one will represent the concept of the sentence, hopefully, and then you can insert it in a small network, just as I showed you before. So this is, let's say, this is a feed-forward network or deep feed-forward network, and then you have, let's say, your final prediction. So this is already like a little bit harder, yeah. But maybe it's also like I think it's also like a bit more logical that you will just insert one word and then another word. So it's kind of the same as reading. So yeah, that's just a recurrent network. You also have an improvement on the one I showed you before, and there's like a lot of things going on. I'm not going into a lot of details because it's pretty hard. But yeah, so one of the problems of a recurrent neural network is that it forgets really fast. So I think it kind of like feels the same way I'm feeling now when I'm gonna get older. But yeah. So the thing is, I'd say with a recurrent neural network, it will probably forget beyond like 10 words. So we'll probably only remember less 10 words, and the rest is, let's say, already forgotten. So you have the LSTM, which is a very fancy network. Let's say there are like a lot of things going on, but where the main objective is to make it remember words for longer. So that's, let's say, the improvement with this one. But the concept is the same thing. You will just insert one word, input back in. So that's still the same, but there's just something more going on under the hood. Is there any questions? I'm happy to hear them. Yes. So then we go to probably the toughest one, and that's the transformer. And I think also the transformer is one of the earlier probably they still use it for Google Translate. This is a very fancy method, where also like way harder, where the model is looking to every word at the same time. So let's say you have word 1 here, word 2 here, word 3 there, and this is a network which is paying attention to many different words at the same time, and is doing so it tries to link words together which are, let's say, related with each other. And then you have some layers of that, and at the output, and if you do that multiple times, so pay attention to words, link them together, and then do that again and again and again, you get some very amazing networks. This one, like I said here, is also like 9 out of 10. Like the previous one, or like this already feels like a lot going on. That's why I already gave, like, say, a 5 out of 10. But like if you just go under the hood for this one, it's just way more. Like this is one of the attention blocks, and this block here is already like one of these things, and this thing over there is already like one of these things. So like this one, it becomes already like really big. Actually, it's, yeah, I mean, I've also made one myself, so it is doable, but like it's way more work than the previous one. So I don't expect you to know it, like how it works. I can, let's say, give you the concept, kind of like how it's working, like roughly. So like every word is going to calculate 3 concepts about itself. So one concept is like what it wants to see in other words. So it's want to know, like, let's say you have the word it, and the word it is looking for its meaning. So for example, you have the sentence, the the what is it, like the rock falls on the cat or something, then, or like the rock falls on the cat and it died. So then the word it has to refer to or rock or cat. So the rock falls on the cat and it died, then the word it probably refers to cat. So the transformer has to somehow find a way to link the word it to cat. And that's kind of like what the whole strength is of this model. So the word it has to find for something. So it looks like for words which are like kind of like stone and cat, or rock and cat. I don't know what I said before. And the words cat and stone, they also have to give a representation what other objects should look for them. And the third one you're going to calculate with a transformer is the value, like what the property is of that word. So there are three different things you calculate for every word, and you do a whole different, like a lot of different layers of multiplication, stuff like that. And afterwards you get some interesting things. Yeah, like I said, it's like really complex. There are like many different things going on. So I don't want to go into too much detail, but it's really amazing. Yeah, so like what are some things they did with transformers? Like I said, Google Translate. It's really good. Like I think used it for translating one of the meetup comments. So you just put it in Google Translate and it works really well. And it uses something like this. So how does this work? Let's say we have a text in English and you'll insert it here. And then we'll try to extract the meaning from English. And this one here has to translate this to, let's say, French or Dutch. So what you will do here, you will just put a part of the translated sentence here, and it will go through this whole thing, and it will predict the next word. And then you do this multiple times, and it will one by one predict the next word. And that's how this model works. Yeah. So also people thought like, okay, this is really cool, but what if we separate things? So what they did is they separated only the analysis part, and that's what they did at the BERT model. I don't know if you guys have ever heard of the BERT model, but it's, I think, what Google's using for analyzing text on the internet. So BERT is made by Google, and it's like one huge transformer. Like this picture doesn't really capture how big BERT is, but it will just insert like a lot of text, and it will try to understand the meaning of the text. Another one which is very new is GPT-3. Maybe you guys have also heard of it. Let's say also like in the news lately, and that's like based on the other part where it predicts the next word. So what is GPT-3 doing? Let's say you insert a small sentence or like a whole sentence, and it will just predict the next word. But it can also be a question. So for example, what they also did, like some trivia. So for example, in this case, and they have the question like, what is solid CO2 commonly called? And the answer is apparently the frozen solid form of CO2 known as dry ice. So that's a trivia question. So what you can do, you can just insert the question, what is CO2 commonly called? And it will probably give the answer dry ice or something like it's known as dry ice. And it's actually something which GPT-3 can do pretty well. So they also compared it. This is, let's say, the history of GPT-3. So this is pretty new. I think this is released like 1 month ago, or like published 1 month ago. It's not released at all. The previous one is called GPT-2. Maybe you also have heard of it. I think it's like 1 year old or something. I don't know. But yeah, the company actually who made this, GPT-2, they didn't want to release it because they were very scared of fake articles. So GPT-2 can already write fake reviews pretty well. So they thought it would probably be kind of dangerous. So they were let's say struggling to release it, but they did it in the end, which is really nice because I can use it for my recipe generator. And GPT-1 I think was like a few years ago, I don't know. But what you can see, this is the trivia, the same data set I showed you before. They found that the bigger the model, so on the x-axis you can see the size of the model. The bigger the model, the better it is actually at answering questions. Even though the model is not trained for answering questions. So actually, if maybe you also have to know that, GPT-2 or GPT-3 or GPT-1, they're all trained by predicting the next words in text on the internet. So I think 10% of the data set was Wikipedia. So let's say they just insert Wikipedia and they just have to finish the whole article. And apparently, by just finishing Wikipedia and other articles on the internet, it was able to perform really good at trivia questions. So it's really amazing. Like one also of the questions people now have nowadays is like, can we extend this, right? So as you can see, the line is still going up. So what will happen, let's say, if the model is even, let's say, 10 times bigger? Would maybe even be as good as, let's say, humans at trivia and stuff like that. So that's, let's say, one of the open questions still. Yeah, so it's pretty interesting. Yeah, also like the general trend in natural language processing is that like bigger models perform better, and people still want to see, let's say, where is the end. So yeah, it will be pretty exciting to follow. I think that's about it. So this was the presentation about how artificial intelligence is interacting with language. I can also like show you more examples if you guys want. If you have questions, I'm also open to listening to them and maybe answering them if I can. So yeah, thank you for your attention at least. And at the same time, well, you guys were probably there's a delay, so let's see if I can find some NLP examples. Let's see, GPT-3. See. That's the API. So I think there are no more questions. Might mean that everything was quite clear. Yes, this one. So maybe also like a funny image. So regarding GPT-3, so actually they also test like if it could calculate. So the GPT-2 was pretty bad at calculating. GPT-2 was this one, and GPT-3 is apparently really good at calculations, which they didn't really didn't expect. So what they did, just like insert like what is like 1 plus 1, and let's say, and it was really good at answering those, but like also like 2 digits, so it could also easily calculate 2 digits. That's these two here. It could also calculate 3 digits, already pretty good, and what is it? Like 5 digits over there. So like it got also really good at calculating. That's like one of the things they didn't really expect from GPT-3 to happen that well. So it's also like really interesting. So yeah, the question is of course like what else can it do if you make it even bigger? But oh well. If there are no questions, I think this will be about it. Let's go back to the slides. Well, at least we hope we can do it live again. I think that's way more fun than online. Well, it kind of works, but yeah, the delay is also like pretty annoying. But yeah, I probably will let you guys know when we have a live meetup again in Den Haag or Rotterdam or Amsterdam. Yes, so I think it will be about it. So thank you for watching.